What we want to demonstrate is that when we run a query for the first time, it will, in this case, when it's a bit more of a complex query, be faster when we execute it for the second time. And we will also have a look at the query profile to see where or how this query was executed and where most of the time was spent. So if I execute this query for the first time, and let me just use actually this compute warehouse. So in this case, I will use the same warehouse when I re-execute it, also with another role. So we will see with another user that we will also be able to do the same. And we will also be able to use this result even if we use another user, but we have to use the same warehouse. So this is with the local storage, basically the local cache results from this warehouse. So let's execute this for the first time, and we will see this might take, in this case, 1.4 seconds. So it was relatively fast. I mean, this table is relatively large, but not incredibly large. I mean, here there are 100 million rows. So yeah, this is actually pretty fast. So 1.4 seconds to calculate this average. And now if we execute it, or let's maybe first have a look at the query ID. So if we click on this, then we will see the query profile, and we can see that most of the time was spent, so 97%. Of the table scan. So we have a pretty large table, and here this had to scan 120 megabytes of this row, and then the rest is, yeah, maybe also some aggregation and so on. And now if we would do this again, so we can just go back to our worksheet. So this was in here, and now if we execute the same query again, it should be a little bit faster ideally. So we can see now it only took a fraction of the time, so only 110 milliseconds. And now if we have a look at the query ID or the query profile, we can see that now it just used the query result. So it used query result reuse, and like this we have gotten just the results. We don't have to execute it again, and it was much faster. And now let's also demonstrate what happens if we use another user. So in this case, I will just set up a new role as well. I will grant usage on the warehouse to this role, and afterwards I will set up a user. Of course, in the end we should also drop the role again. So we drop the role data scientist, and also we drop the user. So after we are done, we can clean up everything again. So this is something that we of course shouldn't forget about. But first of all, we want to just set up the additional user. We want to grant usage to, of course, the role on the warehouse to this role, and then also create the user and grant the role to the user. And now if I have done this and I want to now log in an incognito window to this user, we should have access to this warehouse. And in this case, we hopefully are also able to use the query result, because this has been in the last 24 hours and also the underlying data has not changed. So we should be theoretically able, if we use the same warehouse, to also make use of the query result. So therefore, I will now just go ahead and create a new worksheet, and I will also copy the query so that we use exactly the same one, and I will just paste it. And now if I see that I have also access indeed to the same warehouse, I can execute it, and hopefully it will be also in the same way fast. We can see indeed it has also taken about 115 milliseconds. And if I have a look at the query ID to see the query profile as well, I can also see we made use of the query result reuse. All right, so this is how we can maximize the usage of caching and how caching works. We should run similar queries, ideally on similar warehouses. All right, hope it was helpful, and see you in the next lecture. And of course, don't forget to also drop the roles and the user that you have just created. About clustering, which is a very important technique that Snowflake uses to improve the performance. And this is something that is, again, automatically done by Snowflake, but still we have now some control over this. So this technique is very important, and we want to talk about this. So first of all, we want to understand how this works. So what is actually a cluster key? So Snowflake creates those cluster keys on certain columns. We talk about how this works exactly in a bit and how we can also manually do this. But the idea is to, based on this column, create subsets of rows. And they are then stored in so-called micro-partitions. So this helps to avoid full table scans, because these full table scans is what usually is causing most of the time in the query. So this takes a lot of time to look into all of the data to find exactly the data that we need. And maybe we only need a subset of the data. So with those cluster keys and by structuring the data into those micro-partitions based on this cluster key, we can, based on a query, just know more fast where the data is. So we know we only have to look into this micro-partition, and we don't need to look through all of the data to find exactly the data that we need. So these cluster keys, they are maintained by Snowflake automatically. And this is especially useful, those cluster keys, when we talk about large tables. So this is something when this can be important. And as mentioned, this is maintained automatically by Snowflake, which is of course very beneficial, because then we don't need to spend all of this time to create the primary keys and handle all of this clustering manually. And although this automatic clustering usually provides very well clustered tables, so of course Snowflake is doing a very good job with this, but it is still good to understand how this works and how we can improve it also if necessary in specific situations. So now in this case, we want to understand how this works so that we are able to control this and in some case also customize these cluster keys. So let's have a look at an example to see how this works and in what cases we might even benefit from changing this ourselves manually so that we have a customized cluster key. So in this case, we have this event table. So we have maybe some event date column, and we have an event date ID or an event ID. So here we have all of those event IDs, and we have maybe some additional information, customer, city, and so on. And maybe an automatically created partition might look like this. So here we would just cluster by the event ID. This is maybe some kind of an ID column, and now this would be maybe the partition. So we would have these three, just as an example, these three micro partitions. Of course, in practice in the real world, those are much larger and they are not that small, like only containing 2 rows, but this is just an example. And in this case, we might want to run a query that looks something like this. So we want to maybe filter by the event date. And now this is just structured in the, or partitioned by the event ID. And therefore we might still have to look into all of those other partitions to be able to figure out which events, which data is between the date that we are looking for. So we still have to look into lots of data. And therefore, in this case, if we have such a query, for this query, this cluster key might not be ideal on the event ID. So here we could, for example, use a different type of key. So we could, in this case, for example, indeed, just partition by the event date. And in this case, we get everything between a specific date in one partition and then between another in another partition, and so on and so forth. So you can see here we have the data that we are looking for, and we only have to look into one partition, and we automatically know that this is where we have to look into, and like this we can reduce the table scan time. So like this, we can benefit from this. But I want to emphasize that clustering is not for all tables, but this is specifically beneficial for large tables. And here I'm not talking about the number of rows, but about the data that needs to be scanned. So here we are talking about terabytes of data in size. So here we should be aware that this is where we can benefit. Additionally, the question is, how should we cluster? So which column is the one that we should use as a cluster key? So by which column we should cluster our data? Here we should choose the columns based on the frequency that they are used in where clauses. So by which columns we are usually filtering. So if we have some date column, most likely we want to filter by the date. So in our case, it was the event date. And if this is frequently used in the where clause, well, it might be a very good choice to use this as a cluster key. And also we can use columns that are used frequently in joins. So they might also be a good candidate for a cluster column. And yeah, this is something that we can keep in mind. And also 2 additional points. We have also, of course, that in a column that has a very small number of distinct, it shouldn't be either very small number, nor should it be a very, very high number. Because if we have a very, very large number of distinct values, so for example, let's say every value is different. So for example, maybe it could be an ID column where every value is unique and we have millions or billions of rows, then it has just a very high overhead and it is not very efficient. And on the other side, if we have maybe only 2 different values, maybe let's say, yeah, yes or no, true or false, well, it's also probably not a very good candidate for this cluster key. So it should be somewhere in the middle. It shouldn't be too fine granular, but also it shouldn't be, yeah, only 2 or 3 values. So this is something that we should keep in mind. And now, of course, we want to put this into practice and see how this works, and we will implement this in the next lecture. So therefore, let's already have an overview over the commands that we use to create cluster keys. So we use the cluster by statement during the table creation to specify the cluster columns. So multiple columns can also be used. This is possible, not only one, but also multiple columns. And we can also use an expression in this cluster by statement. So this can be used, for example, when we have a month, but we have only the date and we want to cluster by the month, for example. So like this, we can also control a little bit the granularity, because maybe we frequently just filter also by the date, and then it might, or like the month, and then it might be useful to use the month also in this expression. So we can use also functions and some expressions to control how this should be clustered. Additionally, of course, we can also in an existing table modify the cluster key. So we can just use the alter table command, alter table, and then new cluster key, so we can just change it like this. This is possible using the alter table command. And of course, we can always also drop an existing cluster key. This is also important. Okay, so now in the next lecture, we want to have a look at how we can implement this in practice. What we should take away from this lecture is clustering is in general an important technique for optimizing the performance of our query, specifically for very large tables. This is automatically maintained by Snowflake, but in some cases by careful practice. So we want to see what are the effects of clustering, how we can set up a cluster key on a given table, and in what way we do this to benefit the most from this. So what are the different effects depending on the query that we are using. In our case, we will be using this orders table from our first DB. And if you have followed along with me, then this table should also be there. So you can just execute this select. And of course, if you haven't done this, or if you cannot see any result when you run this select, then just feel free to also execute those first 3 commands to create a stage, and then also load this into this orders table from that stage. So now if you have this table and you want to follow along with me, you can of course now do so. So step number 1 would be to create a new table. This will be just a little bit more of a complex table. So we call it orders caching. I mean, yeah, we talk about clustering, but this is the name of the table just. So we will go ahead and create this table. And now we want to, as I've mentioned, insert some data into this table, and this will be a somewhat randomly date column. And like this, we can just create a sample table where we have some sample data about the date, where we want to place this cluster key on, and we want to also introduce some cross joins just to make the table a little bit larger. And yeah, so therefore I will insert this data, and of course this will take a little bit of time, so just be a little bit patient when executing this, and when this is completed we will be back. So after 4.5 minutes this has completed, and of course in this case you could have just chosen a larger warehouse, so you could have just increased the size to maybe something like large. Just be sure that you afterwards also change it back to small or extra small, so like this it could be a little bit faster for you. And now we want to check the performance without using a cluster key. So this is just the table basically out of the box, and we want to see now how is the query performance, and then afterwards we want to set up a cluster key and compare this performance. So in this case we see it was relatively fast. We have around half a second, and if we have a look at the query ID, we can see that if we have a look at the query profile, most of the time was spent in the table scan. And if we select this table here, this box, the table scan, we can see that in this case 59 out of all of the 59 partitions have been scanned. So this is what happens here. We had to scan through all of the partitions. This is indicating to us that for this query, the cluster key is not set up in a good way for our query. So therefore what we could do is we could alter this to now use a different cluster key and reuse a different cluster key and repartition the table. So of course, when we do this, then the micro partitions will be set up in a different way. So if I do this, now this is a metadata operation, so the cluster key has been changed. And of course, this might take a little bit of time until this is affecting also now our micro partitions. So now if I run this again, of course, I'm using a different date to avoid using the cache. Then I will see probably it might be not faster yet. So we can see it actually took a bit more time, and we will be a little bit surprised, but we have an explanation for that as well. So we can see if I select again table scan, still we are using all of the partitions. So it seems like this hasn't worked. But like I said, this is first of all only a metadata operation, and it might take a little bit of time, so maybe like half an hour or 1 hour until this is reflected actually physically in our micro partitions and that this has been reclustered. So therefore we will wait around half an hour or 1 hour, and then we will be back to check on this again. So I'm back now after about 30 to 60 minutes, and I want to make sure that I'm now trying to do this again. But of course I want to change the date that is used here just to make sure that we are not using the query result, because then we cannot demonstrate how the cluster keys work and how the micro partitions work. So therefore we want to just change the date, and then we want to run this from scratch again. Note that of course, since we are in our case not having a huge table with terabytes of data, this would just take even much more time. Therefore, we might not benefit that much, but we can still show that in our case, the table scan will be reduced. So this can always improve the performance. So let's now run it with this date. And in this case, we can see it is around 900 or 878 milliseconds. So you see, of course, in this case, there was not much room for improvements because it was already quite fast. But if we have now a closer look at the actual query, so if we have a look at the query profile, we can see that this has actually changed how the query was executed. So we can see now the table scan, which usually takes most of the time, is actually much reduced. And now in many queries, this table scan is actually what is really making the query very slow, since we have huge tables in some cases. And then if we have to do an entire full table scan, this will really slow down the performance. So if we now select here this table scan field, we can see that actually there was now only one single partition scanned. So this is now very useful because in this case, we could skip all of the other partitions. So this is what we call partition pruning, which means we can by default, just even before we are executing the query, eliminate all of the other partitions that we don't need to look at because we know there is no data that we want to use in our query. So we only have to look into one single partition. And like this, we can really improve the performance, specifically on large tables, because you can see in this case, of course, it is not a huge table. So you can see that here we can improve the performance, and of course these numbers with the query duration can also vary, and also in your case they might be a little bit different. Something that we have also mentioned is that we can not only use an individual column in the cluster key, but we can also cluster by an entire expression. What I mean by this is, for example, something like month and then date. This is an expression. So if this would be a pattern or an expression that is used commonly in a where clause or maybe in a join or something like this, then we could benefit even further. So this is something that we should keep in mind, that a cluster key can always depend on what type of queries we are using, and it is not always clear what this would be. So for example, if I run this query with the month date, I can see that now with this query, this specific query would maybe not benefit as much as possible, or in an ideal way, by having the cluster key on this date column. So what you can see in this, maybe let me reuse it because I just used it from cache. So let me change it to maybe 12. So then I will get the correct actually duration. So if I execute it again, I can see, it takes a long time actually. So if we have a look at this, we can see we now had to scan a few more partitions. So potentially we could break this down in a better way so that we don't have to scan through so many partitions. This is something that is possible. So we could also use this expression that we use also in this where clause also to cluster this table by. So we could just alter the table and recluster it like this. So this is something that I wanted to emphasize, that depending on the query, depending on what expressions or what columns we use, different cluster keys might be ideal. And of course, there's also maybe a little bit of trial and error, and it just highly depends on the use case. But I hope